Hello and welcome. In this video today, we're going to be talking about hyperbolas. Okay, now you've probably seen hyperbolas before in Year 10 if you've done Year 10 5.3. In regards to this in the Year 11 advanced course, there's nothing really new apart from when we get to something called indirect variation. Now we'll talk about that a little bit later on. I'm going to split this into a few videos to sort of help us out. And we'll go through each of the required skills as we go. Now, you guys have seen hyperbolas before, okay, I hope, in regards to this sort of stuff. Now, for your basic hyperbola, it's any function in this form, y equals k over x. Another common name for hyperbolas is also known as the reciprocal function. Okay, so that's just basically because the x is in the denominator when we have this sort of stuff. Now, you'll see below that I have two separate graphs, okay? On the left-hand side, we have the graph of y equals 1 over x. So this is this one here, okay? And I might just talk about the features of some of these here just before we move on and do anything. You'll notice that there's a bit of a split in the graph going down here at x equals 0. Now, in terms of that, we can see why that's going to happen purely by looking at the denominator of this function, okay? We can't divide by the number 0, so therefore the function that we have actually can't exist there. We call this a discontinuity, and we'll talk about that a little bit more in a moment, but another way that you've seen it known as is called an asymptote. And you'll notice that the function from either side actually approaches that asymptote. Now, when we go down here, sorry, I'll fix that up. When we go along the x-axis, you'll also notice as well that the function doesn't actually touch the x-axis, it approaches it. So that's another asymptote, and that can be achieved simply by rearranging this function into, by switching the x and the y, so it looks like this. So you can't divide by y either when it's 0. Okay, so that's just something to keep in mind when you're talking about this sort of stuff. Okay, so in terms of this, when we want to change up this function a little bit, you'll notice that we have another graph on the right. This is also a hyperbola, and it's also in its basic form. So y equals -1 over x. This one is almost exactly the same graph, except you'll notice that the graph is instead on the top left and the bottom right instead of being in the other two quadrants like over here, okay? And that's simply because whenever we multiply our function by a negative, essentially what happens is we flip it around the x-axis, okay? Some other really, really important things for us to talk about is because our hyperbolas don't actually go through the x or y intercepts in their basic form, we just sort of need to give a little bit of a reference point, okay? Now, what I like to do is I like to substitute an easy number in for the x value or the y value, okay? In this particular case, it's probably easiest to pick this point here when x equals 1. Now, you can see that's where it goes through because of my grid, okay? So this reference point would be 1 and 1, but if you don't have the grid behind it, you need to put that in, okay? The same thing happens over this side, okay? If I let x equal 1, I know that I'm going to get -1 out for my y value. So if I don't have that x-intercept happening, we just need to be very, very careful because we don't actually know what's going to happen, because we can blow these out away from the origin, we can shrink them in depending on the number that we have on the top here for our k value, okay? All right, so essentially when this number on the top, just as a summary, is negative, all right, it will flip the function around the x-axis and you'll be in this quadrant and this quadrant. But when it's positive, as per normal, it's in the top right and bottom left. Now, just talking about the domains, very, very easy to see when you look at the graphs, okay? You'll see that it's pretty much all of the real numbers for x, so that's all of our horizontal numbers except for 0. So when we write our domain out in terms of interval notation, it goes all the way from -infinity to 0. We don't include it, so we use circular brackets. And then we use what's known as a union, okay? So we can join our intervals together. And then it continues on from 0 all the way to +infinity. We have that gap in the middle. And this is the same for both graphs, okay? As you can see, there is that gap happening at 0. This one also has the asymptotes if I go down, okay? And then same thing for the range. If you're looking at your y values, we have all of the y values except for 0, okay? Now, we're going to look really, really hard at these over the next couple of videos when we talk about how these domains and range changes when we change the value of our functions in terms of the equation. But that's going to be in the next video. We'll have a little bit of a look at that. Okay? All right.